Hello everyone. So, um, this is topic 2 of the laws of motion. Fine. And we are going to deal with Newton's first law today. But before we get into Newton's first law, let us try and understand what is the connection between force and motion. Now, in the last chapter, you have studied about motion, the types of motion, and all. You have also studied about contact and non contact forces. But now we need to find out what is the connection between force and motion. Previously, and when I say previously, I mean to say that hundreds of years back, it was thought that for an object to be in a state of motion, one has to continuously keep on pushing it. This was proposed by the Greek philosophers Aristotle and Ptolemy. But it was Sir Isaac Newton who proposed that no, that's not the case. If you push something into motion, the object will remain in motion unless and until you stop it. But doesn't it defy common sense or logic? We know that if we roll a ball, it eventually comes to a stop. Why does it come to a stop? We just now said that once something is in motion, it will remain in motion. Then why can it stop? Well, it stops because of friction. You must have noticed that if there is a near frictionless surface, okay, like the surface of an ice, and once something starts sliding on such a smooth surface, it becomes difficult for the object to stop by itself. It will take a long distance to stop. The reason being the friction is extremely low. And hence, to commit to, for it to come to a stop, it will take a long time. So essentially, if we have an object which is at rest, you have to push it to bring it to motion. Similarly, if an object is in motion, you have to apply a force to stop it. Hence, the connection between force and motion. So, from our everyday experience, we may erroneously think that, you know, there is no direct connection between force and motion. But that's not the case. If you keep a book on a table, it will remain there unless and until somebody or something pushes it. And if something is in motion, it will remain in motion unless and until somebody or something stops it. And this is precisely what we call as the Newton's first law. So Newton's first law basically says that if an object is in a state of rest or motion in a straight line, it will remain so unless and until an external unbalanced force is applied on it. So I'll just write it down quickly. So Newton's first law states that an object in a state of rest or uniform motion in a straight line will remain so until and unless An unbalanced, very important for me. Unbalanced external force is applied to it. So, until and unless an external unbalanced force acts on it, the object will either remain in a state of rest or it will remain in a state of motion in a straight line. Now, let us delve deeper into Newton's first law and try to understand what exactly does it mean for us to understand the nature of nature. So, I'll quickly move on, and now we will try to understand the deeper meaning of Newton's first law. Now, the Newton's first law is also known as the law of inertia. Why is it called the law of inertia? Because this law can be primarily broken down in two forms: inertia of rest and inertia of motion. You must have seen that if you try to move a body, it will not budge, it will not move easily. The heavier the body, the more massive the body, the more difficult it is to move. That means the more the mass in a body, the more the inertness in it, the more the laziness in it, it doesn't want to move. This property of every object in the universe, even as small as an electron and as big as this entire universe, this very property of inertness, laziness, non-responsiveness is called inertia. And this inertia is of two types: rest and motion. So, as I stated, if an object is at rest, it will remain at rest. And if the object is moving, it will keep moving. It's not going to come to a rest. So, when will it come to a rest? When an external, unbalanced force acts on it. Now, the question is, why is it that an external, unbalanced force is required to stop it? Well, the answer to this particular question we will note, we will understand in the next topic. For now, let us understand the meaning of inertia of rest and inertia of motion. Fine. So, as I stated, the inertia or the law of inertia is divided into two parts: inertia of rest. An object at rest will remain at rest until an external unbalanced force acts on it. What about the inertia of motion? An object in uniform motion in a straight line. will keep moving again unless and until an external unbalanced force acts on it. So, in both the cases, the object has a laziness, an inertness, and this inertness, this laziness can only be overcome by the use of an external unbalanced force. Now, let me tell you something interesting. The inertia of rest or the inertia of motion, these are properties. These are properties of matter. But every property has a quantity associated with it, a quantification. Inertia of rest, the quantification of it, the quantity associated, is called mass. So, what is the quantity associated with the inertia of motion? It is mass multiplied by velocity, which we call as momentum. So, inertia of rest is the property, the quantity of which is called mass. So, higher the mass, more the inertia, more the force required to move it. The property called the inertia of motion has the quantity called momentum. Higher the momentum, more difficult it is to stop, more force required to stop it. Imagine a small cycle, barely 5 kg in mass, is moving with a speed of just about 2 meters per second. You can easily stop it. You can just stand in front of it and grab hold of it and it will stop. Now imagine we have a truck or a bus, 5,000 kilograms of mass, going at the same 2 meters per second. Can you stop it? No way. Or imagine a bullet, just 100 grams in mass, but going at 500 meters per second. Can you stop it? No, you can't. In both the cases, we have momentum, extremely high momentum, extremely high inertia of motion. And the higher the inertia of motion, the more the force required to stop it. Now, the next thing that we have to understand is certain examples from our day to day life. Fine. So, let us move on and let us see some examples from day to day life. So, I'll just break up this thing in two parts. We will have inertia of rest on one hand and inertia of motion on the other hand. Now, you're sitting in a vehicle, in a car, for example. This is you sitting in a car, and the car suddenly starts moving forward. What happens? The lower part of your body, which is in contact with the car, also goes along the car. But the higher part of your body, the upper part of your body, it is still at rest. So as the car moves forward, the lower part of your body moves forward, but the upper part of the body wants to remain at the same place. So we tend to fall backwards. The same car now going at a constant speed, and you are sitting on it. It's going at a speed, let us say at a velocity v. The car is going at a velocity v, you are going at a velocity v, and the car hits a wall. Boom. What happens? The car comes to a stop almost immediately. The lower part of your body in contact with the car also comes to a stop. But what about the upper part of your body? It is still in motion. So you fall forwards. Inertia of rest, inertia of motion. Another example. You want to find or you want to get some fruits from a tree branch. So we have got a tree branch. And we have some mango attached to it. Fine. So what are you going to do? You are going to shake this thing violently. When you shake the branch violently, what happens? This mango or the fruit, it is in a state of rest. It doesn't want to move. So the connection, fine, it breaks and the mango falls. Inertia of rest for you. What about inertia of motion? Well, you have the fruit in your hand and your friend is standing approximately 200 meters away. Very difficult for you to throw it. So what you do? You run with the fruit in your hand. And after you have gained some speed, you throw it. Why? Inertia of motion. You're gaining momentum, which is then imparted to the fruit, which keeps flying and reaches the intended destination. So, similarly, there can be n number of such examples that will tell you the difference between inertia of rest and inertia of motion. But we have not discussed about one more type of inertia. It is called the inertia of direction. Yes, this is the third kind. The inertia of direction comes into the forefront when we try to move something with an angle. If something is going straight and we want to move it, we want to turn it, the inertia of direction comes into play. Things don't want to get turned. For example, you are sitting in a car. Fine, this is you sitting in the car is going straight. And then suddenly the car turns. What happens to you? You are still going in the straight direction. So you feel as if you're moving out of the car. It's called the centrifugal force or a pseudo force. We'll talk about it later. So essentially, what is the inertia of direction? When something suddenly turns, the body doesn't want to turn accordingly. If you're standing inside a bus, and the bus suddenly turns, you have to hold on to something, otherwise you'll fall. Will you fall in the direction of the motion? No, you'll fall in the opposite direction of motion. That is because of the inertia of direction. So what have we learned today? We have learned that there is a thing called inertia, which is inertness of every object in the universe. It is because of this inertness that objects don't want to move if they are at rest. and they don't want to stop if they are at motion. And this leads us to Newton's first law, which states that if a body is in a state of rest or uniform motion in a straight line, it will continue to do so until and unless an external unbalanced force acts on it. So I hope in this topic you have learned a few things. Thank you.